Welcome to the lecture on control of distortion in welds. So, we have studied about distortion which is caused in the weld and the reasons for those distortions. And now, in this lecture we are going to have discussion about those methods which should be adopted to control or minimize the distortion in the welds. So, coming to the distortion of welded specimen, as we know that the distortion of welded specimen often lead to unacceptable deviations from design dimensions. So, that is to be mentioned, and residual stresses and distortion to a large extent behave in a contrary way. So, many a times it is desirable to have the low value of both residual stress and distortion, because otherwise you need to you have a lot of loss, or you can have the decrease of the productivity which take place in the case of distortions or so. So, that we have already studied. Now, we always feel or we always desire to have a condition of no stress and no distortion, and for that the best method is the annealing process. But if there is improper method of annealing, if there is no proper technique is there, or proper temperature is not chosen, then that may result into some other undesirable effects like warping may occur or so. So, there are many methods by which should be adopted. There are many techniques which are required to be followed to reduce the distortion. Now, the mostly the apart from the annealing, because in many times we go for the annealing, but if you take the improper temperature, if you do improper way of annealing, like that involves the heating rate or cooling rate or holding. So, that is also certainly one of the way, but then apart from that you have other methods also to control the distortion in the welds. So, the first method is the least root gap. So, these are the methods which are which are used for the control of distortion in the welds. Now, these methods include the least root gap. As we see, you have proper tack welding, you have narrow groove section, direction of welding, least metal deposited, welding sequence, backstep welding, counter setup. So, all these methods are the ones which should be followed, which this should be practiced to ensure that there is a minimum amount of distortion that is taking place. Coming to the first point, that is least root gap. So, we know that while I hope that we all are conversant with these terms like root or gap, or I mean then you have the angles, included angles, type of joints and all that. So, one of the step which should be followed is the maintaining a least root gap. So, the root gap should be as small as possible, and basically although you keep it small, but then it has to be sufficient for the good penetration. So, that criteria you have to keep in mind, that the penetration should be good enough. Then what we do normally is that so that is why we try to avoid these excessive gaps, excessive value of the root gap. So, normally the practice is that included angle should be not more than 60 degrees. So, that way this practice needs to be followed to avoid large distortion. Now, this is a common practice that when we use the heavy section, in those cases we try to have the double V type of instead of having single V, you try to have the double V type of section which is preferred over the single V. Then the next way to control the distortion is the tack welding. So, tack welding is basically used for the accurate fabrication in seam welding. Many a times we do the seam welding where you have to do the welding continuously for the larger length, and in those cases, as we have studied, depending upon the welding conditions, there may be distortion taking place. The edge may come closer or that may go apart. So, that may lead to the distortion of the specimen. So, that depends upon many conditions. But then to avoid one of the method is the tack welding. So, you make the tack welds. So, especially in the seam welding process, this tack welding is of much use. So, this should be sufficiently long to reliably transfer the shrinkage forces. So, certainly that should be it should be sufficiently long. Now, normally what we do is the normal practice is that the tack weld length, now that is normally kept at a value of about 2 to 3 times the plate thickness. So, that is the normal practice of having the tack weld. However, there may be hardening and cracking of the weld also, and that may occur if a small volume tack welds are applied as compared to especially for the large volume components. If you put the small tack volume, in that case there may be hardening and cracking of the tack weld. So, that because of the heat transfer phenomena or so. So, that may be that is likely to happen in those cases. Now, for those cases when you have the chances of hardening and cracking of these small tack welds. Now, in those cases what we do is we normally do the preheating also. So, when we do the tacking, so that time we also do the preheating. So, that avoids this hardening and cracking of the tack weld. So, also there are possibility of the formation of cracks also, and other defects due to when you weld over the tack welds. So, that is another possibility which is coming. So, it means to counter that you have to have different processes should be adopted, like you must have the cleaning mechanism, you must have the preheating mechanism. So, these needs to be practiced to to avoid any kind of problem or defect because of the tack welding. Next comes the narrow groove section. So, the groove section, as you see, so the groove section should be as narrow as possible, and that is practically feasible to permit the smallest possible heat input, and filler material in conjunction with highest possible heat concentration for welding method. So, that way you should have the you have, certainly there is a limit to everything. So, the groove should be as narrow as the possible one, because we know that the higher will be the heat input, larger will be the heat content. So, that way larger will be the chances of distortion because of the heat. So normally we try to have the narrow sections, and you try also to have the highest possible heat concentration. So so for that we take that kind of the welding methods. Then so in those cases basically fusion zone and your plastic deformed zone are small. When you take these these methods or these practices are adopted, in those cases your fusion zone and the plastic deformed zone, they are small. So that gives you lesser the distortion. So you have to have the proper groove design to be selected, and normally what you do is that you take the square groove and which has the smallest possible groove cross section, so that you normally take. You also take one of the groove section preferable as compared to other, like U shape will be preferred as compared to the V shape. So that way we have certain guidelines which should be followed. Then if you have the symmetrical weld groove, so that is preferred because that will reduce the shrinkage, but then there may be induction of the residual stresses. So there are some practices followed, like you try to use the double V instead of single V, or double sided fillet weld preferred instead of single sided fillet weld. So normally you go for the symmetrical weld groove. So this is as far as the use of the narrow groove section is concerned, these practices should be followed. Then comes the significance of the direction of welding. So in what direction the welding should be promoted. So normally the condition is that, or the preferable way is that the direction of welding should be away from the point of restraint, and it should be towards the point of maximum freedom. So wherever, in whatever direction you have maximum freedom, that in that direction your welding should move. Then another point which needs to be kept into consideration is the least weld metal deposited. So normally you have to see that there should be least weld metal, because larger will be the weld metal. So that will induce more and more contraction, because that every metal, when it solidifies, it will contract to a certain extent. So if for any joint, if for joining any particular two component, you are having a joint and one of the joint takes more metal, in that case there is likely to have more contraction in that case. So so whenever you use the excess metal, that will increase the probability of having distortion more. So so weld should be made to drawings. So you must have a standard set of drawing which is supplied to you, design, and then amount of weld metal is that way defined. So you should not give extra amount of weld metal which should basically increase the chances of distortion because of the larger metal being present there. Then comes the significance of welding sequence. So basically what sequence should be followed for the welding. So what is important is that if you properly control the welding sequence, properly select the welding sequence, then you can control both the sign and magnitude of the deformation. So, by having the proper welding sequence, basically you can have the control of the both the sign as well as the the magnitude of the welding the deformation. Now, if you have the job of a large surface area, so consisting of several plates, then in that case the transverse section should be welded first, and then that should be followed by the longitudinal seams. So, normally that is the practice which we follow, that when you are dealing with those large surface surface areas which is consisting of different plates. So, in those cases first you go for the transverse sections, and then you move towards the for the longitudinal layers. So, that is for the that kind of structure. Then when we are dealing with the welding of I or H beam section, then first to be welded are joints within each web plate and the flange, and then we do the butt joint between the web plate and flanges of the beam. So, that is when we do for the I and H section beams. And when we talk about the cylindrical vessels, so many a times we are doing the welding of the cylindrical sections. So, in those cases where you have different tires. So, in those cases as compared to the contrary to the plates, so here what we do is we do the welding of the longitudinal seams first, and then we go for the circumferential seams. So, that type of welding sequence has to be practiced for when we are talking about the welding sequence. So, depending upon the structures, we should first do the longitudinal one and then move towards transverse, or opposite way you have to move. So, that depends upon what kind of shape or structure you are welding. So, this is the practice or the significance of the proper welding sequence. Then you have the next point, which is further important, is the backstep welding sequence. So, this is normally used for to contract the wedge shaped opening and closing. So, that is the rotational distortion of the weld groove ahead of the weld pool. So, it is normally occurring with regard to the long welds and at low welding speeds. So, normally for those cases we use this backstep welding sequence. So, what is what we do in this case, that we are doing the welding in a back manner. So, in this case the groove opening is suppressed by the prior tack welding or by rigid lateral constraint or restraint. So, this may result in permanent rope shaped arcing of the weld joint. So, that is happening in these cases. So, what we do normally in this case is that we normally make the tack welds. So, tack welds are first made, and now that also depends upon what is the welding speed. So, if your welding speed is low, in that case low spacing between tack weld has to be there. So, if you are moving at a slow speed, in that case there should be spacing between the tack welds, that should be smaller one. Then first weld layer, what we do is subsequently deposited in the back step sequence. So you are moving in the back step. So this is a welding direction. So you are moving in that back step sequence from tack weld at one end to the opposite end. So that way we do the the welding sequence, and then you go for the after that you apply these layers continuously and alternating so that way you move. So in these cases what is happening is that there will be good melting through of initial sections of the welds, and the workpiece warpage that will be diminished using this backstep welding sequence. It also results into the reduction of the transverse and longitudinal shrinkage of the weld joint as a whole, and normally this is very much a practice for the manufacturing of large structures like ships or tanks. So there that is this backstep welding sequence is very much a practice to control the distortion. Next if you use for the if you go for the other methods which is also followed, that is your counter or opposing setup. So sometimes that also is being used. So you can have the opposite effect on the distortion. So warming the warpage which is caused by the internal stresses, so that can be controlled effectively by these counter or opposing effect on So normally what happens if you look at a T joint. So in those T joint you have so if you take the example of a T joint. So here warpage will be occurring because of because of contraction of weld. Now as you know, you might have some idea about the camber allowance in the case of casting, where what is happening that when you have a joint vertical horizontal portion which is likely to sag. So and that is distortion in those cases. So what we do is we normally give an allowance. So we give that upward bend so that even after sagging it becomes straight. So that is camber allowance in the case of casting. So similar concept is here also. So we normally give a slight reverse bend so the vertical member, if you are giving the slight reverse bend or counter camber, so normally that will lead to the control the distortion in those cases. So basically counter or opposing setup is also one of the efficient way to control the distortion. And if you talk about the if you take about the butt joint with a single so if you take the butt joint welding of two plates with single V edge preparation. Now in that case what we do normally is that we provide a backing strip also. So under that joint, so so that the increased opening is formed. So for that we normally provide a backing strip. So so accordingly after the welding the plates will align themselves. So that also helps you to control the distortion. So so that is one of the way also to control the distortion in those butt welded plates. Then another way also. So, if you come to other methods, so normally we also many a times we have to deal with the distortion of plates, thin plates and sheets. So, that is a challenge to control the distortion, but because in those cases we know that in those thin sheets the warpage probability is maximum. So, one of the very method which is normally adopted is the use of copper chill blocks. So, whenever we are welding the thin sheets, in those cases what we do is we are keeping these copper chill blocks, because in those cases in the case of thin sheets the transfer of heat so rapidly through the sheet is itself a challenge. So, so placing that we place those copper chill blocks under the job. So, that what it does is it will try to extract the maximum heat from the weld, and if that heat is extracted, then that will certainly reduce the chances of warpage or the distortion in that sheet. So, so that is one of the very popular method. Then we also use the water cooled jig also many a times. So, you have the copper tubes bridged to the copper holding clamps, and then water is circulated through that tubes. So, during the welding. So, that way if that basically decreases the temperature, in those cases there is it is likely that your distortion will be smaller. Then you have some other way also to reduce the distortion in the case of plates, and that one is the method of fixing. So, you try to have the frame as rigidly as possible to avoid the bending and angular distortion. So, that way we go for these are the different methods of controlling the distortion. Then once there is distortion, then there must be certain way also, because there is some amount of distortion which has occurred in the weldment. Then there are also certain ways to correct these distorted elements, and for that there are many methods also. So, you can do the correction of these distorted weldments. So, there are different mechanical means also there, and you have thermal means are there. So, suppose you have mechanical methods are there. So, among the mechanical methods, like once many a times when you do when you look at the welded specimen, then they are somewhat deformed, somewhat welded, somewhat warped or so. So, you can use the machines, heavy machines like press, or you may use the rollers, straightening rolls, you can use the jack screw also sometimes to. So, in case of minor deformations, you can use these methods to basically reduce the distortion in the weldments. Apart from that, there are also thermal means. So, you use the thermal source. So, you use different type of arc or torches, like you may have oxyacetylene torches or carbon arc, or you may have the powerful oil or gas burners. So, you will have to use these thermal means only for those materials where its property is not affected because of the increase in the temperature. So, in those cases we also use these thermal means to control the distortion. So, these are basically the different ways to control the distortion of the weldments. So this is in nutshell talking about the distortion which occurs in the welded specimen, mainly due to the thermal imbalances relating to the properties of the material, relating to the heat transfer through the material, relating to its improper fixing, presence of restraints. Many a times the expertise of the welder. So these are the different so because of that the distortions can occur, and how can you control. So we have got some idea about the correction about the distortion of the weldments. Thank you very much.